Welcome to week 4. This week we are going to start our topic on circles. So this is going to be broken into 2 lessons, and the first lesson is an introduction to circles and some of the vocabulary. So a circle is a set of all points in a plane that are equidistant from a given point called the center of the circle. So looking at this image on the right, which letter do you think represents the center of the circle? So if you picked C, you would be correct. And the way that we write the notation is we draw a little circle with a point in it, and we'd say that this is going to be called circle C. So we always name a circle based off its center. The distance from the center to a point on the circle is the radius of the circle. So you may be used to be calling this segment joining the center of the circle to a point on the circle as the radius, but radius is also going to be considered a distance. So which of the following would be considered a radius of this circle? So in this case, BC or CH would be considered radius, or if we want to say more than 2 radius, we call them radii. So BC and CH are radii. So 2 circles are considered to be congruent if they have the same radius. So if I have 2 circles, let's say I have circle A and circle B, if they both have the same length radius, so let's say this one has a radius of 2 and so does this one, then circle A would be congruent to circle B. The distance across the circle through its center is called the diameter. So just like the radius, diameter is not only a length, but it's also a segment. And the diameter is always twice the radius. So which of the following would be considered a diameter in the picture above? So in this case, BH would be considered the diameter because it passes through the center C. So let's say, for instance, that I told you that the radius of circle C above is 3. What would be the length of the diameter? Well, it would be twice the radius. So if the radius is 3, then the diameter would be 6. A diameter is actually a special type of what's called a chord. A chord is a segment whose endpoints are on the circle. So which of the following would be considered a chord? Both BE and BH are considered chords. So BH, we said, was the diameter. That's a special type of chord. It's actually the longest possible chord that you can have in a circle. But since the definition of a chord is also a segment whose endpoints are on the circle, BE would also be considered a chord because the points B and E are on the outer edge of the circle. A secant is a line. So let me just differentiate here. Chord is a segment. Secant is a line. Remember, lines have arrows. And it intersects the circle in 2 points. So when we did the chord, it had 2 endpoints on the circle. So what would be considered a secant then of this circle? So you may have noticed that I wrote 4 different secants, but it's actually all the same secant. AF, AE, BF, BE, they're all the same secant. But the difference between a secant and a chord stops on a circle. So its 2 endpoints come to a halt. Okay, it should not be exiting the circle at all. A secant passes through the circle and continues on. So that's why when I wrote BE for the chord, I put a segment on top. And when I wrote BE for the secant, I put 2 arrows on top to differentiate between the 2. The last thing that we're going to talk about is a tangent. A tangent is a line in the plane of a circle that intersects the circle in exactly 1 point. That point at which it intersects the circle is called the point of tangency. So which of the following would be considered a tangent in the image above? In this case, DG would be a tangent because it comes and it passes through. It touches the circle in one spot and then keeps on going. What would be the point of tangency? If you put E, you're correct, because E is the one spot where the tangent is touching the circle. Now, if I wanted to, I could name this tangent DG. I could also name it EG, or I can name it ED. These are all the same name for that tangent, except here I'm using the point of tangency in my line. So you may see it written in a couple different ways. So now here are a couple more examples I'd like to give you a chance to try. You're going to use this diagram, and for 1 through 8, you're going to tell whether the line or segment is best described as a chord, a secant, a tangent, a diameter, or a radius. So please try number 1. Is AB a chord, a secant, a tangent, a diameter, or a radius? AB would be considered a chord because it has 2 endpoints on the circle. How about the second one? Line DE. Because it used the notation with the arrows on top, that means it's passing through the circle. It's not stopping. So we said anything that passes through the circle is considered to be a secant. Number 3, line segment DC. Line segment DC would be a radius because it joins the center, which is C, to a point on the circle, D. Line segment DE, be careful with this one. Line segment DE would be a diameter because it used the segment, which means it stops at D and E, and it passes through the circle. So notice for 2 and 4, if it uses the arrows, it's a secant because it passes through. If it uses the line segment, it would be a diameter because its endpoints are on the circle. If you chose chord for number 4, I would have accepted that as well because a diameter is a special type of chord. Number 5, line FG. Line FG would be a tangent because it touches the circle in one spot, point G, which is its point of tangency. Number 6, line segment CG. That one would be a radius. Number 7, line segment EG. That would be a chord because its endpoints are on the circle. It's not a radius, it's not going through the circle, nor is it a diameter because it's not going through the circle. And number 8, line segment EC. That would be a radius because this time it's connecting the center of the circle to a point on the outside of the circle.